we might have 20,000 blockchain developers. Would you say that's about right, Ian?
Probably lower than that.
Yeah, maybe 10,000. But think about, juxtapose that for a minute. 20 million Java developers globally, and that's just Java. That's not C++, Python, PHP. I mean, you can go through the whole, all the proprietary stuff too. Anyway, we have Ian today. Ian has taught at NASA. He's worked at Microsoft. He's probably one of the most adroit blockchain developers we have in the Pacific Northwest, maybe the entire USA. Guys, big round of applause for Ian.
Thank you for the wonderful introduction. Hopefully I can figure out how to plug in my laptop. That'd be great, right?
You don't have to program that.
Right.
It's a hard part.
Oh, you guys are in
Hardware
for a
problem.
treat today.
So my answers would differ slightly from the answers that the previous presenter gave. And Ronnie asked me to play nice. So
Well, I just didn't want to be here till midnight.
You know what I mean?
So I read his documentation on the code attacks when he was presenting. The first one that he gave was, he said quantum cryptography and quantum computing is never going to basically crack Bitcoin. He said it was infeasible and it's going to take longer than the universe has been around and more power than the sun. But there is this mathematical problem called the quantum Fourier transform, which works really well on quantum computers. And it's similar to looking at a clock and waiting for it to go around and say, well, in 65 minutes, what time is it going to be? And they can solve that problem very quickly on very large numbers using the quantum Fourier transform. And so they're able to essentially look at the elliptical curve of our private keys and our public keys and figure out where the private key is on that curve using that transform by just checking to see if the curve solves that problem. And it can go very fast. So that's one of the ways in which I would argue against his presentation. Your question regarding can the blockchain group protocol, BGP, use as an attack vector against Bitcoin? Absolutely. I can announce incorrect routes inside BGP without a security key, without authentication at all. I just have to hack into one of the Cisco routers that is a member of the BGP announce group, announce a new protocol endpoint, and I just taken out a whole mining group. So now I get all of those transactions and the other miners are offline indefinitely until I switch to my mining pool and I collect the mining pool transactions. Just one command. One command on a Cisco router. There's insecure Cisco routers everywhere I could break into. So that's a very real attack vector. Mesh networks are an effective local or wide metropolitan area system. And I was part of the anonymous effort in order to get Egypt back online by putting all of the Wi-Fi routers in ad hoc mode. We sent them literally boxes with Wi-Fi routers and instructions, put them in ad hoc mode, connect until you find someone who's online, and then you can path away to the internet or to each other by using those ad hoc networks. And that was a very large mesh network. So huge cities were all online using a mesh network, using Wi-Fi routers. But that's still vulnerable to the BGP announce problem because they still have to get data in and out of the country. And when the people in power, I forgot his name, decided to shut down the internet because, I'm sorry?
Morrison?
I think you're correct, but I'm really bad with names. He had the French monitoring systems for monitoring the traffic on the block on the BGP. What is it called?
Border gateway.
The border. Well, it's actually announced blocks. It's on border.
BGP is free blockchain. It's an old protocol.
Yeah, but I mean, no, it's very old. I used to program it in 2000 in Silicon Valley in order to get our Cisco routers talking to the Cisco routers and say, yes, we just licensed a new block of a /26 to add to our other /25 to add to our other /24. And so we have to announce that those IPs belong to us using BGP. But I thought that because the addresses came in blocks, we were announcing what blocks of addresses that we had on the block control. It could be border, it could be right. But he put in on the ATM switches, he put in the actual monitoring software and then shut off the wire and just disconnected the whole thing. So the other attack is this one, where there's a 256 private key, which becomes a 160-bit address, but there's a birthday attack. You can look up birthday attack on Wikipedia, it's pretty easy to do. Basically means that in this room, there's a 50-50 chance that two of you have the same birthday. So you don't need 365 people, you only need 23. And then there's 2 to the 92, it's a 4 followed by 27 zeros. Different private keys to equal the same public address. So we're just going to generate a lot of them. And that's another attack that's been used by 5 groups I know about, one being a large Bitcoin collider to actually take money out of wallets. We had it up on the screen before it showed up. So those are real things that I differ slightly from his attack vector list. So in the last year of doing everybody's distributed application except my own, I ended up running into a bunch of issues. And Leep Network embraces my solutions to those challenges and the problems that we have basically getting Bitcoin to work for business. One of them wanted to have a monthly payment schedule, and there's no time. There's no time on blocks. The block verification time varies. On Ethereum, it varies by 20% up and down. When people are hopping mining pools in order to game the difficulty curve, it changes a lot. So 20% over a month is a huge number. They might pay 3 days early, we might charge them a late fee. So the fact that there's no time is a critical issue. Like, this offer expires in 24 hours, plus or minus 3 hours. Multi-part transactions. So basically, you do a transaction, it's all done in one bit. One transfer, and that's it. You can't say, well, we'd like you to deposit funds before we pay you. Now, if you have a distributed application, you can kind of work around that, but it's a server workaround. It's not on the chain. Doesn't occur on the blockchain itself. It's a bunch of extra code somewhere else. There's a smart contract way of doing it, but how do you get the data into it? You have to use a system called oracles, which I'm not going to cover, but they're really, really expensive. Or you push the data into the contract, which means you have a server somewhere. So you're not really able to do business on the blockchain. You're doing business connected to the blockchain. Bitcoin, Bcash, Ethereum, almost everybody, every single node processes every transaction or it drops off the network. If you can't keep up, you're off. Right now with Ethereum, they're processing at max 3 billion transactions per year. And with modern hardware, SSDs, just doing one thing and one thing only, I can't keep it up. We have to wait for the network to have a bunch of empty blocks before that machine can catch up. It can't stay on the network. I've had some hellish problems doing stupid workarounds. I got it to work. I sell my workarounds. And people pay for my workarounds because the APIs are bad. If you're doing an Ethereum transaction, the blocks are 15 seconds. Assuming you're willing to pay 5 times as much as the next guy, the browser might come back with a response in 45, 90 seconds. But then you have to wait for confirmations. Do you really have the money? You think so. So there's a lot of problems with that, what they call settlement or finality. It would be an hour to cover the technical details of all of those things. But those are all very serious problems.
Can I ask something?
Sure.
When you say blockchain, you refer to a public blockchain?
I'm sorry?
You refer to a public blockchain?
Yes, that's what he's talking about right now.
Okay, but
Public blockchain.
what about a private blockchain? Are those all adoption problems that you are listing, solved with a private blockchain?
So that's half true. Let's say that you made your own copy of Ethereum and you ran it in-house. And it's you and your friends. And only you and your friends can connect to it. What purpose does it have?
Yeah, I agree. So you've got another problem, which is, your connections of your private blockchain with other private blockchain, and to be able to exchange between blockchains, this is another adoption problem.
That's the cross-blockchain problem. And you have to do contracts on both sides. In Bitcoin, you can do that. And you can do that in Ethereum as well. Though the problem with doing the private blockchain, in my mind, is how do you get people to use it? You say, hey, please put this really fancy machine in your network and spend a lot of time in order to give me all of the money from it. It's really hard on a business case, and it's really hard because you haven't solved any of these problems. You haven't. The only one you've done is you fixed scalability by having no traffic. That's the only one of these problems that you've actually solved. You're still going to have 30-second, 45-second block response if you have 15-second blocks. The only one you solved is you made an empty network that nobody uses. That's what you get for using a private blockchain. All of these other problems, you still have all of them. It doesn't benefit your customers unless you really, really, really couldn't talk one-on-one. In my mind, you're better off exchanging JSON and not dealing with blockchain at all if you want to have a network of 5 nodes. When you hit around 10 nodes, and you have 10 people that want to share data, you're still probably better off with an email distribution list. Blockchain's a bad way to do it. You can. If you need to have a bunch of devices that are pushing data into it, and those devices are all capable of talking to your blockchain, it's okay. It'd be an okay solution at that point. Because you have all of these devices that are sharing data into that blockchain. You want to read those results, and they are always online, and they've got at least 2 gig of RAM, and it'd be okay. But otherwise, a private network just resolves the scalability problem by having no traffic on it. So the insecurities. Birthday attacks, right here. BGP attack, right here. When you break the network into small pieces, you can attack them independently. So if you can make so people can't talk, you can use a smaller amount of hash power in order to attack each of those networks. When they shard Ethereum into different systems, or you use like the credits.com sharding method, you can attack the individual chains using less resources than required to attack the whole network. But when you do those sharded networks, you gain some scalability, but they still have to talk to each other. And their method of talking to each other, like for example, using the Cosmos sharded network system, you can interrupt their communication with BGP or a single command where you forward traffic, and then their denial of service blames they blame the denial of service attack on one of the other peers, and then their anti-denial of service code kicks in, and boom, they don't talk anymore. Good luck trying to get that removed. Scream at the ISPL you want. No, it doesn't require any hack. It's just one command on my machine. I've done it. It's really easy. Bad or no crypto? IOTA says that they're quantum safe because they don't use cryptography. That makes them quantum safe because I don't even need a quantum computer to attack it. NEO, the NSA put backdoors into P256. It's well acknowledged. They paid, the technical white paper for Leep actually has the references on where it was announced. It's easy to find. Hyperledger uses really bad had bad code. I looked up some of the security holes that they had, and they didn't use basic cryptographic safety checks. So you can replay and impersonate people on these blockchains. It's just the space is riddled with bad crypto. I looked at the latest version of credits.com Java code. There's no nonce. Java's insecure against side channel attacks. You can read the private key out of somebody's machine. Just tons of problems like that. You want to see a bunch of new attacks? Look at Verge. They hacked that to pieces. There was something like 8 independent different attacks that occurred on Verge in the course of 3 months. They're really good. I liked it. I just don't want to put my money on it. So, smart contracts. They're immutable. Can't fix them. Whatever you wrote, whatever you publish, that's it. It's done. You can publish a new contract later and people might use it. Maybe. And it's really hard to secure against these things. I've written against buffer overflows for a long time. I've done 20 different programming languages for money, more for just playing around. So I had a strong security bent ever since, I could take over most of the internet back in 1999. And I thought, well, the security thing is important. So I looked at how to write secure code. And I studied how do I write secure code for a long time. And it is a hard problem. Most contracts and smart contracts are written by some outsourced Ukrainian or Russian group that just wants to get paid. They don't spend the time to learn how to write secure code. If you come up with this brand new smart contract language, it'll take the developers 3 to 12 months before they even figure out how to write more secure code on it. I sat studying all the security exploits that had occurred, came up with a couple that weren't on the list, but were then revealed later by other people. And then I started writing what I considered secure contracts, and they are dead simple. I don't do a whole bunch of function inheritance. I do very simple statements. If you don't know the state of every variable in the loop that you're in, rewrite it, make it simpler. That paradigm, unfortunately, is an uncommon one. People write complex things because they think it's more elegant. I write simple things because I think they're more secure. Ethereum had a lot of cracks, hacks, exploits. Some of them were published, some went undetected. There was another group in February, $2 million. It was relatively unannounced. It was a buffer overflow. Someone did a comparison. Instead of checking for an equal sign, they had a greater than. Send too much of user input data, get millions of dollars. Really simple.
Yeah, I don't want to pick on you being the presenter too bad, but I think in all fairness, it's reasonable that in a group like this, that you have to contextualize kind of the gravity of what some of these vulnerabilities are and what some of the opportunities ahead of us are for solving some of these problems. Like, let's take the multi-signature contract.
Oh,
One of the issues with that isn't so much that you can't create a contract because they're immutable. It's that we need to take different approaches to how we develop the contract.
Correct.
Such as, an example would be, we need to make a social contract with the community that says the community agrees to support this contract, and if it fails, then we'll do a work to fix it.
Okay, so you're actually talking about the rest of my presentation. I've actually covered all of these things you just said. So thank you. Thank you for the preview.
Wait, are we ready for questions then? Did he
You guys can jump in, but maybe you guys should. I'm not saying that it's impossible. I'm saying it's hard. I'm saying that
it's pretty practical as long as you negotiate these things in advance. The problem is people are going fast and breaking things because they want to make progress, and the networks are growing a little faster than maybe the durability.
And I like Callisto's audits and governance, and I like a couple other features, and I borrowed some of those features. And I think that it can be done. I'm just saying that if we pick the new programming language to be more secure, it's going to start off not being secure. We have to learn how to use it. That's my point. It's not the language that's insecure, it's our implementation. It's us as developers. And there's a learning curve. That's my point. And the problem is that after we learn that it's insecure on Ethereum, we can't fix it. And I'm going to provide a solution to that too. So what we're doing to make this better. Solutions. Transaction time should be very quick. You don't need to talk to the whole network and wait for confirmations. We're only going to talk to the people that are interested in your transaction. If all of them okay the transaction, we'll give you a pre-approval and then we'll submit it. Once it's submitted, it's done. The pre-approval means that you're probably safe right then and there. The submission, 6 seconds later, is when you've reached finality on our network. If you look at finality for Ethereum on proof of stake, something like 20 blocks, finality is reached a significant time later on. In the case of Bitcoin and stuff, it's hours to reach finality after the block has been mined. A DAG is a really elegant, complicated, and simple thing. When you're cooking food, you put lots of stuff on the stove. You're doing these things in parallel. When you're done, everything's on the table. That's a DAG. That is a directed acyclic graph. You didn't repeat the same step with different results. You put the ingredients in, you can stir them multiple times, but you're stirring them for a different purpose each time. And then the closure, the idea that you've concluded everything, is that everything ends up on the table. Now, IOTA claims to have a DAG, but there's no closure. It's just all over the place. They use Markov chain random verification for part of the transaction. And they only reach finality when the decider, controller, what do they call that thing? When their central database finally approves you.
Oh, yeah.
So just basically closure is the idea that you've asked everybody involved. Now in your modern OS, they'll boot up with a directed acyclic graph. And they'll say, oh, this is a networking service. Let's wait till networking is turned on. The dependencies are handled automatically. And then we'll do all of the things that we can in parallel. Everything we can't do in parallel, we wait till the dependencies are solved, and then do that process. At the end, the user can log in. And that's closure as well. If there's some service that doesn't start, then you don't have closure. If there's some error, if something ends up in the trash can because it got burned, that does not have closure. So it's a mathematical property of that graph. I'll cover this later as well, but the idea is that we're going to allow multiple people to talk. It won't just be one off and done. So the wallet security. If you can do this once a week, and the large Bitcoin collider was what, once every 10 days?
I don't remember the numbers, but yeah.
And you use that same network against us, it takes 10 to the 26 years to come up with the same wallet collision. That's pretty close to solved. It's practically solved. I actually know crypto and hired specialists in crypto, and this crypto thing, we're not going to just fly by the seat of our pants and hope it works. We're actually going to do our work. I've got a lot of paperwork on just all the different attacks that can be done against networks, and I'm writing a few in order to attack the network and the wallet, to attack the security of the system, and I'm going to actually execute them. And then I'm going to execute them against my network and make sure it succeeds. I'm going to make sure the network is up and it does not have any failures before I call it ready. And it's easy to attack these things. Unfortunately, it's cryptographically hard. You have to know what you're doing, but it's a couple hours time in some cases, and a couple days in others. There's a really good, famous fake article on how I stole 32,000 Ethereum after a bad Tinder date. It's on Medium. And he covers exactly how to do every step to scan the Ethereum network for the Gavwood multi-sig vulnerability by hex code. He published it after all the money was secure. This was something he did a month after everything was all done, but covers his steps fairly well. But it's fiction. It's fiction. So DAG-based proof of stake. I don't want to get into that too much. If you have technical questions, we should probably cover them without holding up everybody's time, because it will be gibberish to everybody else. But if there's a problem, if we think that there might be a double spend, there'll be a no vote. That no vote says, whoa, stop. And that's within the DAG. We will check for that no vote before we give that approval. If there is a no vote, it goes into a completely different rule set, a completely different set of conditions and checks, validation and rules. If there's no votes, and someone has bad RAM, we can let the thing continue. But if there's a no vote, we're doing a full stop for a little while. We'll give it an extra 10 seconds. Immune to the 51% attack and the 33% proof of stake attack. These are proof of work mining, if I can make more blocks faster than you can, or I've taken out 3 networks that mine blocks, and so my network is bigger, then you're able to do a double spend. You're able to transfer 10,000 Bitcoin and then spend it again, and then you're able to make both transactions valid, and you're able to go faster than the rest of the network. Since there's 3 large groups, if you could take out all 3 mining groups, is not part of 3 commands instead of 1 on the BGP attack, then you only need to have something like 3% of the current hash power in order to take over Bitcoin. We don't care. We're not mining. If the machines that are required to be known, and we actually have a list, it's actually a maintained list for this transaction, here's who you have to ask. If we can't get a hold of them, well, we're putting that on hold. We're going to figure out what's wrong before we do an approval. So just the idea, the assumptions made in the 51 to 33% attack from valid.
And that model of your network is vulnerable to DOS attacks. Substantially.
Okay, so I'm going to go a couple more slides and then answer that. So if there's an offline, if one of these machines is taken off the network, right? If it's just kicked off, what do? Well, that should be redundant data to begin with. There's no single point of failure or we failed. We want to have that data replicated. It's just we're not doing 100% replication to every single node on the network. We'll have a fast mode and a slow mode. The fast mode is everything's running smoothly. Might have 4 or 5 redundancies. And the slow mode is we might have 10 or 20 redundancies. And we'll tune that. I'm going to attack it, break it, and then make it so I can't break it. When I can't break it with double the power, because I'll do test networks and I'll make another test network that attacks the first one, then I'll feel more comfortable. I'll know what the parameters should be. But it's a parameterization question partially. And that collection of rules and if-then statements, verifications, delays, we're calling pollen. And so a layer on top of the network. So this is the slow and the fast. The worst case scenario, if I don't have any good rules, is that we'll default to the same security as the other blockchains for proof of stake and validation. That's I think a failure on my side. I'm not being able to predict what an appropriate response is. But at the very least, I'm as secure as the other guy. I want to skip ahead to answer your question, and then we'll go back. Okay. So you're saying that we'd be vulnerable during that point? We're actually able to have pollen query the other database nodes and the other scribe nodes. There's three kinds of nodes that we're going to be dealing with. Databases, app nodes, which are basically doing lots of code. They would be the ones executing the actual smart contracts. But we're not going to trust one, we're going to run it through 3 of them, or 5 of them, and make sure they all come up with the same answer. If they don't, we're just going to do it again with different people and see what the result is then. And then scribe nodes are just like some guy sitting on the corner writing down everything. You can ask him questions because he knows. This is where a lot of the data will be cached. You'll be able to reverse lookups capable. You'll be able to ask about the state of the network. You'll be able to ask about polling and implementation and rules. And their job is just to pay attention. So you're saying I'd be vulnerable during that. And I'm like, well, these scribe nodes are picked pseudo-randomly. We take the hash of transaction, and the hash of the transaction tells us what the minimum number of scribe nodes addresses will be. So everybody knows who's supposed to be asked, but they don't get to pick who's asked. Does that make sense? I don't know. Did I answer your question sufficiently with that? Okay, great. When I first started blockchain development, it sucked. I had no idea where the data was located. They were written in the same language sometimes on Walk, on Gap. There's a bunch of nomenclature, and best practices were nowhere to be found. There was a bunch of old documentation that wasn't valid anymore by this company called Consensus. You'd think would maybe maintain their documentation and examples. And everything was antiquated. There was no good example for me to follow. So we're going to come up with a series of decent examples in an MVP state. Just, hey, look, you could publish records to the blockchain. And in an advanced configuration that shows a full use cycle. And I want these to be different styles of MVPs. I want these to be different kinds of networks, different kinds of transactions, different kinds of databases that are queried. Because it's not going to be one size fits all. You'll hopefully find something near what you want to do, copy and legally paste that code, and then build off of it. Don't reinvent the wheel, follow best practices, and then add your special sauce. Add what makes you unique, not the thing that everyone has to do. If you have to repeat everybody else's code, that's a bad system. You should be able to just work on your code, not all the code. So, big data. One of my good friends here, Chris, he's got 500 million data records to publish. He wants it to be a blockchain-enabled platform. There is no way you're getting 500 million records into Ethereum. It is not going to happen. Partly because each gigabyte costs you 32,000 Ether. That's a lot of gas. That's a lot of money. So if you're trying to publish 1 gigabyte and the current price is 300, what, $1 million? Or is it 10 million? I think it's 1 million. No, it's 10 million. It's $10 million. That's per gigabyte. That's kind of expensive, yeah? So what we're doing is we're saying that you can have your data indexed and accessible. Your dApp could contain the lookup keys, or your contract could contain lookup keys, or a lookup method, or insert your query here. And we'll query that big data, charge you on result, not up front, but if there's no results, then there should be no fee. It's up to whoever writes that. they can charge for a zero result. They could charge a minimum transaction fee for zero result. But the idea is that you'd be able to have these huge data sets, like the addresses that Chris has, where you'd be able to say, hey, what's the restaurants near me? And you could ask this blockchain faster and cheaper than you can ask Google. Because Google now is charging unless you're using a phone. If you want to have a map location show up on your website and you have 10,000 hits, it's like $2,000. But that's your data. It's in your database. You don't have to publish the whole database onto the blockchain. And we can encrypt the result and send it out so that everybody could read it, but only you can read it. Because this public key, it becomes a private. This private key becomes a public key, which then becomes an address. That public key in between, we can use as an encryption target. You've exposed it by submitting a transaction, so we'll send to your public key your result, which you decrypt using your private key. If they don't have your private key, they can't decrypt the result. If it's a big response, then we'll also encrypt it with AES. I like AES 256 because that matches the security of our 448-bit keys. But if you're using a browser and it's a video, we'll use AES 128 because that's what will decrypt automatically by the browser. Some of the media coin technology is getting implemented into this. Some of the stuff I worked on is becoming part of the Leep Network. I was all about enterprise data sales, so I thought of this for last year. Different ways of implementing it. So we're going to provide gateways between your database, whatever it's in, and the blockchain queries. So you don't have to write that code either. You don't have to write all these weird Oracleized Passover security connections. We want to write that connector. Part of the reason is that we want to make sure that we do this safely using asset compliance and transactional systems. So if you're doing a multi-part sale, like let's say there's a Lamborghini that's sitting in inventory supposedly, and you want to buy it with your massive trading wins because you can draw triangles really well on the screen. We want to make sure that Lamborghini is actually in stock before you send them the money. Well, how do you do that? Asset compliance. If the Lamborghini is in stock using a transactional query, then we'll accept the money if the seller agrees. So you might even say, well, what color is it? And that could be included as part of the query, even though it wasn't part of the transaction. It'll become part of the whole flow of that transaction. It can be a complex transaction, not just, here's my ETH, I hope it works. Or here's my Bitcoin, I hope I get what I want. I hope it gets delivered. You can make it so that the money automatically goes into escrow, and then when the ship with your custom BMW arrives from Germany, then the money unlocks. And we can make it so the port authority is part of that transaction. We can make it so it's a multi-party transaction, not just, here's my money, please make sure you pay me what I asked to get back someday. So that decreases the risk of fraud, and it increases the complexity of the transactions that we can perform. So the light chain implementation, I keep saying blockchain, blockchain, blockchain. We're not going to put every transaction's details into the block. We're just going to put the summary. What's the result? So if a large network, some private network, has a bunch of internal transactions, don't tell us all of the transactions. just tell us about what came in, what went out, and publish that. And we're going to use pollen to make sure that you aren't cheating your customers and that we know what the data was. We're going to know about those transactions. But we don't need to publish that on the actual block. We're just going to publish the minimum of what we need to know, the minimum of what needs to be shared among those databases. And by publishing the minimum, we can increase the throughput. By sharing less data, we can get more transactions in. But the other details will be there. They'll be accessible. We can ask, we can find it. Just most of the time, we don't care. We don't care what someone ordered on their pizza. All we care is if there was enough money in the account to pay for it. So, semi-private. One sec, I want to cover this one. I'll answer. I'll field your question. Semi-private means that if we're keeping all of these details off, and we've provided enough verification, so your little group has done their transactions, and you're able to talk amongst yourself for the most part, that means that the whole blockchain doesn't have all of that data. It's not permanently published for everyone to see. They can ask you about those details, but we might have flexibility in how much you're required to tell. And I say that because what's safe and trusted and private are three different things, and it's a balancing game. Where we draw those lines depends on the data and how critical that data is. If it's money, we care more. If it's more money than you have posted on the network, we definitely care. You can have that as a reserve balance, but we can adjust this as a slider scale. So privacy can become an option, but we need to do it safely. And safety is my main concern.
I was just going to ask you if you're familiar with Grin, and if so, how this compares to their implementation.
I missed the name.
Grin?
Grin?
Grin, yeah.
I'm not familiar with them.
Okay.
I've read 100 or so white papers in the past. A couple months before I wrote mine, seeing what the state of the art was. That wasn't one of the ones I ran against.
Okay. Yeah, I'm just digging into it, so I'm curious.
There's a couple of groups that have really good tech. I just don't think that they solve the problems that need to be solved.
Okay.
I like Cardano. I dislike Ripple's ability to reverse transactions. They're a central bank of shared protocol. There's opinions vary a lot on a lot of these technologies, and I think the proof is more in the pudding than in the white paper. But I think that a lot of people have good ideas, and then I'll flip through and I'm like, this is a good idea. Page 17, I can break that. Everything he said up to this point hinges upon this one thing that I can easily break. And my autism kicks in, and I'm like, oh look, there's the attack. And one of those was a vote-based distributed acyclic graph for doing different kinds of transactions. And he had this really neat flow chart and stuff. And I said, nope, simple attack. Just by making a large number of machines that talk to each other, increase their reliability amongst themselves, pump some money into it, pump some trust into it. And then I shard it and then double spends or quadruple spends because it'd be easy. It broke the whole thing. So I'd actually have to read their paper in detail. And if their technical paper is actually technical, I'd appreciate it. If it's just a fluff paper, I don't want to bother.
Yeah, how we looking at time?
I'm close to 30, so I should speed up. Although we've done some of the Q&A so far, at least. Gateways, the idea here is that, let's say you come up with a novel approach to make Swift transactions show up on the blockchain, and then everyone goes, that's a really good idea. Well, you can just charge for that in protocol, in gas, as royalties every time someone uses your system. If you're a new database connector, you can charge royalties for it. If people use it, they start using your database connector, you should get paid. So I want to make this business friendly in lots of ways, and one of those is just honoring those royalties. So I'm going to speed through this a little bit, partly because it's hard. So let's say that someone does some tokens and they proof of stake the ticker symbol CAR on our network. People can just send money to CAR. They don't have to send money to your current contract, they can just send money to CAR. And so you can switch and upgrade your contract over time. But, as was stated, you want to make sure that, one more slide. If it's an unfair upgrade, they need to be able to block that. And that's the social contract you were referencing. The biggest and easiest way to get cross-blockchain transactions is to include the cryptographic primitives. If you can't talk SHA-256, it's really expensive to do it in gas. But if you just say, hey, look, it costs 2 gas to do that, it's much easier to do those cross-blockchain transactions. It's easier to bounce between the networks when you include the cryptographic primitives. And I just don't think that there are enough primitives available. Just adding more primitives for different kinds of transactions would really benefit everybody. I have to speed up, and we covered most of this already on glyptos and ASIC compliance. So this is a huge security versus privacy versus legal compliance that's become an issue. Every business that accepts money is required to know who sends them that money. And it's stupid. We're not talking money laundering for $1, but they're treating it as money laundering for $1. So we want people to be able to register their address and KYC the address so the business can just say that information is available and we have met our legal requirement. And that's the whole point of all of this. It's just making sure that businesses can say, yeah, we met the legal requirement, without having to spend $8,000 set up and $1.20 per customer. Because some of these things are microtransactions. It's artists selling music. But the artist has to do KYC on their customer. On the other hand, it's becoming a legal requirement everywhere, so if you're going to be in business in a year, you have to do it. It's better to do it in one central place so that the fee is paid one time and it's a low, reasonable fee as opposed to a stupid high fee. We can get a database subscription to the anti-money laundering list, and then we don't have to charge every person. We can just pay one fee. So governance, the idea is that we should, as a social contract, be able to say what happens on the network. I think that the ETC, the Ethereum Classic fork shouldn't have happened. They should have asked people. But no, one developer decided and they announced it as a patch, and some people maintained the original blockchain, and other people implemented a code that reversed the transaction. And I don't want my opinion to be the opinion that wins the day. I want people to vote on it and say what should happen. I think that if these things are done in the light of day, as opposed to backroom deals, that we'll end up with a better legal strength than if we just corrupt whoever's able to submit patches. This is a defense against the individual attack. It could be that the individual isn't allowed to corrupt the network in code or in bribery or other methods. And just having that done in governance in the light of day, I think is better than doing it privately. And I've got some very interesting Skype chats among the Ethereum developers if you want to read them. So we're aiming for fast, secure, scalable, time synchronized. You'll know what time it is in a million blocks. Precisely, to the minute. Probably within 6 seconds. You'll know. I really don't like the Ethereum keeps breaking things. I think that you should pass the unit test before releasing code, and then you should upgrade your documentation. The implementations for this are bigger than blockchain, I think, because multi-part transactions can, although they can be done inside smart contracts, so smart contracts get more and more convoluted. And what happens is that as you start asking more questions outside that block, you're delaying the transaction longer and longer and longer, and then it fails without ever having it processed. So it's important to make all of the information available, accessible, and let there be delays if necessary. Put expiration dates on things. You can. It's not hard. It's just not done either. It's not done yet. So I actually don't like proof of stake. I really don't. Partly because I think it's too easy to leverage a win against one network to attack the next. So I came up with a bunch of defenses to make proof of stake better. One of the problems is that there's nothing at stake sometimes. Unless you actually penalize bad behavior, then bad behavior is just profitable. If I can make $10 million and lose 10,000, sounds like a good deal to me. So what's proof of stake in big numbers? So I'm scaling proof of stake required to process a transaction. That's a Paulin rule. It says, hey, look, you can't process a $10 million transaction on 10,000. It's just not going to happen. We're not going to let you. We're going to make it so that there's more money at stake. Forking and sharding private networks, there should be no benefit. One of the ways that we're dealing with that, I skipped over it slightly, was DAG tagging. The idea is if you own a bunch of machines that can mine and act as nodes, you can say, hey, look, these belong to me. And my transactions will, by default, go to those machines. And if I've got extra capacity, I earn money. If I need extra capacity, I can use the whole network. And there's no reason not to. So I'm anti-fork because I think it shouldn't be necessary. We should make a better system that makes it unnecessary to have private networks. And then we're going to find green is sustainable because that's something that all of us care about. What I want to be doing in a year is making a sustainable city. And I've found a group of people that have similar goals and similar values, so I really appreciate that. We are doing ICO Law Group as our law firm, doing Sept and SEC Reg B. There's a foundation in Mauritius, and the reason that Mauritius was recommended is because they have a clean legal framework for this sort of thing. If you do a Swiss one, you have to have a lot of money, number one. And number two, you're actually dealing with a bunch of really arcane trade rules. Things involving cattle. So this Mauritius is a small island near India, but it has a clean legal framework and they're considered in compliance by the rest of the world. So that's a better way of doing things. Cayman Islands was like the corporation they picked. I was recommending Singapore, but they picked Cayman. There's different reasons for both. We can't take the money and run. Our tokens are worthless, can't be traded or sold for longer than the investors. Basic thing. And we're doing SEC rules for securities, as if for security, despite we're also doing an exemption, but we're still following the rules, even if we didn't have the exemption. So I just like the belt and suspenders method of legal compliance. Why set off alarms when it's so easy to follow the law? We might do an ICO in October, but I don't like the idea of doing a really quick ICO in a really bad market. We're mostly doing private funds. We have some potential partnerships that I'm not allowed to discuss, but I think that those partnerships would give us a very large ICO around the November timeframe. These large companies just do not work that fast. So I think that November or December is more reasonable. And we've been working for nothing for a while. And I want to personally get the testnet up and running before we start doing any kind of public announcements or public ICOs or public solicitation for funds under the SEC Reg B. So, thank you very much for your time.
Guys,
Questions?
big round of applause.